So we were talking about how to, by using this method, how we can determine the interval in which we have the ROI. Okay? And now, since the interval becomes very close between 9 and 10, and since 141 is closer to 0 than 251, then you can say, I can try, for example, 9.35, for example, let's say. If I try 9.35, I will get NPV nearly equal to 1. So you can stop here. And to obtain 0, it's very difficult to obtain 0 al ad. So it's fine. So NPV is very close to 0. So I can say that nearly the ROI is 9.37. If you do more calculation, you can get it more closely. Okay. So and if you perform more iteration, you get that nearly the ROI you obtain is equal to 9.3475. Okay. So here, is this ROI good or not? It is relatively good. Why? Because this means that for A smaller than 9.345, okay, NPV will be positive at year 20. NPV 20 will be positive. So I have a large interval of confidence. So I can work in this project for low confidence countries or high confidence countries. So my project is acceptable here. So it's very important to have a high ROI, okay? Because if I have a low ROI, this means that I am restricted only to zones where I have a very high safety, and I can always have risks, okay? So this is for the first question. The second question was to calculate the payback period. Let me check the question. So the question was to determine the discount rate if the payback period is 10. Okay, so now they are asking a different question. What will be the payback period? What will be the discount rate if the payback period is 10? So now what will change in my methodology? Who will tell me? If the payback period is 10 years, this means what?
Yani at year 10 we will have the...
Very good. At year 10 we will have NPV 0. Then what will change in the formulation I did? What will change? It will remain the same formula. And here if I replace...
But miss when we talk about the payback period, we don't consider the time value of money.
No. انتبه انت هون عندك discount rate يعني في time value بس ما في أول شيء salvage value. You do not include the salvage value first. يعني here the payback period is calculated as the discount rate for the payback period is calculated as follows. I follow the same methodology, but first I say that instead of NPV 20 equal to 0, I say NPV 10 is equal to 0. Okay. So because NPV 10 is equal to 0, so first in my expression, everything will remain the same, but here, when I do the summation, I don't do it from 4 to 20, I do it from 4 to 10. And here I will replace the power exponent 20 by power 20 by power 10. Okay? Because I calculate only the summation until year 10. And plus the second modification, I will not include, and here also, of course, I put 10, and here I put 10, and I will not include the salvage value, because the salvage value is only included for the last year, okay? So for year 10, I should not include the salvage value, okay? So here I will get NPV then at year, I can compute NPV at year 10, okay? And as we said, we replace all coefficients by 10 and we exclude the salvage value. So now, also, it's same method here. We have NPV function of A. So we should do some iterations to know what is the corresponding value of A to get a discount payback period of 10. So now same methodology. But who can tell me A will be smaller or higher than ROI here?
It will be smaller.
Very good. Why? Because if you have more confidence in the future, you can have a payback period that is smaller. The ROI, if you want, correspond to the discount rate for which the payback period is 20 years, which is the lifetime of the equipment. More you are confident in your future, then your payback period will be reduced. Okay? So since a discount rate of 9.35 nearly gave me a payback period of 20 years, so to obtain a payback period of 10 years, of course, A should be much lower than 9.345. So from here, you can say, I will start by values of A that are relatively small. So for example, I can start by 2, by 3. Example, I can say that for A equals to 2, okay, if I replace in my formula of NPV10, if I replace in NPV10, I will get a positive value. Because I got a positive value, then I will be sure that A is higher or smaller than 2. Who will tell
Higher.
me? Higher. Very good. Because if I want to have a lower NPV, I should be less confident in future. So I can use now, try to use A equal to 3. If I try A equal to 3, then the NPV at year 10, I expect that it will be lower. Now, if it is negative, then it's very good. So I can say that my A is between these two. Okay. The value calculated is minus 197.5. So yes, I can be sure that A is in between. But I can be sure that it's closer to 2 than 3 because 94 is closer to 0 than 197. So now, for example, if I try, let's say, 2.3 nearly, okay? So let us say I try 2.3. For A equal 2.3, I get my NPV equal to 4.54. So I am very close to 0 now. Okay, I am very close to 0. So I get equal to 4.54. So now if you just do some little bit more, look, Anna, I want you to understand the method. I will test, I will put the test in a way to test your concept. This is why you can use the Excel sheet if you want, but you should know the steps. You should understand the methodology and know how we iterate, why we decide to increase A or to decrease it. This is what is important for me. Okay. So now with some little bit more iteration, you can get that A, the corresponding discount rate is very close to 2.3. Okay, is equal nearly to 2.32 nearly. Okay, so nearly it's 2.32. Okay, so this is so once you can see here, once you have done the first step, the other questions becomes much easier because now you have all your terms and just you should get your new equation to answer what they want from you. Okay, the final question was to for a discount rate of 5%, calculate the payback period, the discounted payback period. So here also it's the same method, but they varied the variable. So instead of giving the payback period and asking about the confidence rate, the discount rate, they gave the discount rate and asked for the payback period. Okay, so here also I can use the same relation. Okay, but instead of saying that is NPV 10, okay, I want to find the year. So now what I will write is the following. I will write for this equation, the unknown now is the year n, okay? So what I will do, I will put NPV function of the year, NPV at year, small n I will call it. So it's any year between 0 and 20, okay? What will change now? A is known. I don't put it as A now. I can directly replace it. So I replace A by 0.05, which is 5%. Okay. So I replace A in my whole formula function of 5%. And instead of the coefficient 10, I will put n. So to the power n. Okay. So now n is unknown, but A is known. So I will just replace 10 by n, which is the year, and I will replace the discount rate by its value. So by replacing A by 5%, by replacing A by 5%, okay, the unknown in the equation will be n. The unknown of the equation will be n, okay, and here also, or I can use the calculator, or I can use the iteration method. So I will try several values of n until reaching the corresponding value. But here I can have a prediction. Look, how can I do the prediction? For a discount rate of 2.32, what was the payback period? 10. So now, do you expect that if the discount rate is 5, the payback period will be higher or smaller than 10?
Higher.
Higher,
than 10.
because my confidence in the future is lower. So of course the NPV, the year n will be here. I need more years, okay, to have a balance, to have the balance equal to 0. So from here I can directly start by a year that is higher than 10. So I can start, for example, let's say I know that n is higher than 10. So I can start first, let's say, by n equals to 12. If I do n equals to 12, I get directly NPV minus 1, which is very close to 0. Okay, so I can be sure that nearly the payback period is 12. Okay, so when you know how to do your assumptions, or your if you want your the choice of your variables, then you will directly reach the accurate solution, even if you don't have a powerful calculator, or even if you don't introduce your equation in calculator or Excel. Okay, so that's it. This is mainly, in this problem we have nearly revised all concepts for chapter 8. Okay, so I want you to very well understand the effect of variables in the economical analysis, because questions can be numerical or can be, if you want to test concepts. So how will vary, for example, the payback period with A, how it will vary with the ROI, etc. I can ask many questions based on what we did together. Okay.
Doctor, can you post this solution on Moodle?
Yes, I will, of course.
Thank you.
Okay, welcome. Any other questions? So good luck for the exam, and if you need any help, you can send me a message whenever you want. Okay.
Okay, thank you, Miss.
Bye.
Thank you.
Thank you.
Welcome.
Miss,